Okay, we talk about simple interest. Now we want to talk about compound interest. Okay, simple interest, as we said, is calculated based on your principal. Okay, compound interest is computed on your principal and also on any accumulated interest. So it's not only on your principal but also on your interest too. So when they are calculating your interest, they actually consider your principal and the amount of interest that you have as well. Okay? So there are so many saving accounts that they pay compound interest. Okay? So one thing is that compound interest, well, if it is, if they calculate it once a year, okay, we call that annual, okay. So the period of time between two interest payment, we call that compounding period, okay. Well, when it is calculated, when they calculate your interest once a year, okay, so we call that compounded annually. Okay, it means that n is equal to 1. They calculate your interest once a year. If they calculate your interest twice a year, okay, we call that compounded semi-annually, okay. In that case, n is equal to 2. If your interest is calculated 4 times a year, it means every 3 months, right? 4 times a year, n is equal to 4, then we call that compounded quarterly. Okay? Well, let's say you have a plan that calculates, your interest monthly. We have 12 months a year, right? So n is equal to 12. So that's compounded monthly, okay? N is equal to 12. So here's the equation that we have: compound interest paid in times a year. So let's say you deposit P dollars, that's your present value or principal P, right? At a rate of R. R, it needs to be in decimal when you actually want to calculate it in this equation in decimal form. And it's subjected to compound interest, that is calculated in times a year. So that's n. Okay, how many times a year they are calculating your interest. Well, the amount of A, future value, okay, is given by this equation after t years. So t is time, okay. So future value is principal times 1 plus r over n to the power of nt, okay. So again, guys, don't forget, if your compound interest is paid, 1 times a year, once a year, n is equal to 1, right? So it's annual. It's compounded annually, okay? If your compound interest is paid twice a year, n is equal to 2, that's semi-annual, right? N is equal to 4 is compounded quarterly. It means every 3 months, right? So compound interest is paid 12 times a year monthly, right? So it's compounded monthly and it's equal to 12, right? Well, we can have compounded daily too. They actually calculate your interest every day and they pay your interest every day, right? So it's daily. So n is 365. Some banks they go with 360 to simplify that, right? So it's like, compound interest is calculated daily, right? Every day they calculate your interest on your interest and your principal, okay? Here we go, and that's the equation that we have for compounded and times a year. So let's say you deposit $2,000 in a saving account at your bank with a rate of 6%. Okay, so your present value or your principal is $2,000. Well, annual rate is 0.06, 6% is 0.06. Find the amount A. You want to find, your future value. Okay, after 3 years, so time is equal to 3 years, subject to interest compounded once a year. Okay, so n is equal to 1. Okay, and part B, find the interest. Okay, so I know that future value is equal to principal times 1 plus r over n to the power of n times t. N is equal to 1, right? So I just place 1, right? In the equation, I just plug in 1 for n. So A then is equal to P times 1 plus r to the power of t, because n is equal to 1, right? So n is equal to 1. So A is equal to, then P is 2,000 times 1 plus 0.06 r to the power of t, t3. Here we go, right? I just plug in the values. N is equal to 1, t is 3, principal is 2,000, and r is 0.06. So guys, be careful. Here, the whole bracket is to the power of 3. First of all, you need to find out the bracket, okay? So 1 plus 0.06 is 1.06. Whatever it is, that's then to the power of 3, okay? First, I have to find out the value in the bracket, right? Then calculate to the power of 3. Then calculate the power, okay? The exponent. Okay, 1.06, okay, to the third power, okay, so whatever it is, multiply the result by 2,000, okay, so 1.06 to the power of 3, multiply that by 2,000. So you get something around 2,382, right? Yeah. So whatever this value is, you multiply that by 2,000 and we get something around $2,382. Guys, this signs that I used means approximately. If you want to put equal, that's fine, okay? I just want to show that that's approximate, okay? Here we go. Now part B, it says what is the interest? So guys, we always know that interest is the difference between future value and your present value, right? So because we know that always future value is principal plus interest. So interest is actually future value minus principal. So future value is around $2,382 minus present value or principal is 2,000. So $382, right, is your interest. Here we go. Now here it says you deposit $7,500 in a saving account that has a rate of 6%. The interest is compounded monthly, okay? Well, you deposit $7,500. That's your principal. The account has a rate of 6, so 0.06 is your R. The interest is compounded monthly, so N is equal to 12, right? Monthly we have 12 months a year, it means your interest is calculated 12 times a year, so n is equal to 12. How much money will you have after 5 years? So time is 5 years. You want to find your future value, and in part B, you want to find your interest, okay? I'll give you around 1 minute to answer this question. If you need more time, you can pause the video, okay? So go ahead. Don't forget to write down what is given to you and what you want to find. Okay. So you deposit 7,500. That's your principal or present value in a saving account that has a rate of 6%, so R is 0.06. The interest is compounded monthly and is equal to 12. You want to find out how much you will have after 5 years, so time is 5 years. You want to find out how much you will have, so that's your future value. Okay, we know that future value is principal times 1 plus R over n to the power of nt. Okay, so it's equal to P is 7,500 times 1 plus R is 0.06 over n, which is 12, to the power of 12 times 5. So, sorry, it happened. Okay, so A is 7,500 times 1 plus 0.06 over 12 to the power of 12 times 5 is 60. Guys, be careful. Something really important. First of all, you have to find out 0.06 over 12. You need to find out this value. Whatever it is, add it to 1. Always, okay? So, A is equal to 7,500 times 1 plus. So, 0.06 divided by 12, okay? So, it's 0.005, okay? To the power of 60. So, first of all, you find out this ratio, 0.06 over 12. Whatever it is, it's okay. Add it to 1 on your calculator, okay? Now my calculator shows that 7,500 times 1.005. So first you find out 0.06 over 12. Whatever it is, add it to 1, okay? well, to the power of 60. Now, be careful. First of all, you have to calculate this exponential, okay, function, this exponent, whatever it is, then multiply that by 7500. Okay, some people by mistake they multiply 7500 by the number in the bracket and then to the power of 60. That's wrong. First of all, you need to find this power, the bracket to the power of 60, whatever it is, then multiply that by 7500. Okay, use your calculator. Okay, so 1.005 to the power of 60, use your calculator, to the power of 60, whatever it is. Okay, multiply that, whatever the result is, multiply that by 7500. Okay, so I got something around $10,116.4. Okay, so I just plug in the values. Okay, first of all, you have to find this ratio, whatever it is added to 1, then to the power of 60. Okay, first you need to calculate the power, whatever the result is, multiply that by 7500. So we get something around $10,116. Okay, here's the future value. Now part B, it says find the interest after 5 years. Okay, well, interest is the difference between future value and principal. Okay, here's your future value, here's your principal. The difference between these two values gives you the interest. So interest is future value minus principal. Okay, so around $2,616. That's the amount of interest that you get after a period of 5 years. So for compounded interest n times the year, we have this equation. For simple interest, we have this equation. Okay, so that's compounded. First one is compounded n times the year. Second one is simple interest option. But always, for any option that we have, doesn't matter, any option that we have, always future value is principal plus interest, or interest is future value minus principal. Always, for any option, this is always true. Okay, so here it says you deposit 7,000 in a saving account that has a rate of 6.5%. The interest is compounded semi-annually. How much money will you have after 10 years? And then wants you to find the interest after 10 years. I give you 1 minute to answer this question. And, well, if you need more time, please pause the video and then I solve this question. Okay, go ahead. Don't forget to write down what's given to you and what you want to find. Okay, so you deposit $7,000. Okay, so that's your principal. $7,000 in a saving account that has a rate of 6.5%. So R is 0.065. The interest is compounded semi-annually, so N is equal to 2, right? Semi-annual, twice a year, N is 2. How much money will you have after 10 years? So time is equal to 10 years. How much money will you have? It wants you to find the future value. Okay, and then part B wants you to find the interest. Okay, what happened? Okay, here we go. So future value is principal times 1 plus R over N to the power of NT. So future value is 7,000. I just plug in the values, right? Times 1 plus R 0.065 over N, which is 2 to the power of NT. N is 2 times T, 10 years. Okay. Again, guys, don't forget to find out this ratio first. Whatever it is, add it to 1, then to the power of 20, okay? So, use your calculator. So, 0.065 divided by 2, whatever it is, add it to 1, okay? When you have this bracket, whatever it is on your calculator, okay, then the result to the power of 20, okay? So, well, to the power of 20, okay, whatever the result is, multiply that by 7,000, okay, times 7,000. So I got around 13,270.9, around that. So I got something around $13,270.9, or you can write down 13,271. Okay, so approximately. So here is the future value that we have. Now part B, it says find the interest. Okay, so we know that future value is principal plus interest, or we know that interest is future value minus principal. So interest is the difference between future value and principal. Now we have future value is around $13,271 minus principal, that is around $7,000. So you get something around $6,271. That's approximately the amount of interest that we will have after 10 years. Okay, I'm gonna stop here, give you a break, and then we will talk about continuous compounding. Okay, just let's have a break.